Before I introduce myself, why are delta tables important? The attempt of Microsoft in Fabric was to bring all the analytical data solutions into one place, and it's great. But we have to keep our data somewhere. We need a database. And for that, they put in the Lakehouse and the warehouse. So the Lakehouse is the center of Fabric. But Lakehouse needs files to hold the data, and these files has to support every analytical workload. So we need file types that can support our analytical workload while still giving us the benefits of a database like transactions, updates, deletes. So this is the idea of data tables, and we'll go into it deeper on this session. So just to quickly introduce myself, I'm Chen Hirsh. I'm a data engineer. I've been a data engineer and BI developer for the last about 15 years. Currently with Madeira Data Solution, we are a small company that work in data solutions for our customers. So you can see if you want to connect on LinkedIn, if you want to see my blog, this is the addresses, and you have the barcode, and you can scan it. But let's get down to business. Before I start explaining about the internals of the data, let's go and see our, just going to go ahead and step out of that. And I want to show you the Lakehouse, which I'm sure everybody in here knows, but I'll explain anyway. Our Lakehouse is where we hold all our data in Fabric, and it has two parts, the files parts and the table part. So in files, we store every file that is not a delta table. It can be CSV, TXT, ORC, even PDF, images, Parquet files. Okay, so here I have a folder called Northwind and a lot of CSV files inside. In the table part, all tables, you can see my order tables has some columns. It will reload in 2 seconds. Okay. But behind the scene, you can see that this table has a little triangle icon that says it is a delta table. All of the tables in our Lakehouse are delta tables. And behind the scenes, if I want to see what's behind the delta table, the actual storage, I can go to view files. Oh, okay, little late, but here are the actual data. I can go to view files, and I can see what's behind my data. So I have a few Parquet files. Okay, so now we know that the data behind the delta table is actually stored in Parquet files. And we have our delta log, which is our transaction log. We'll talk about it later. So I want to take you step by step in creating a new table and see what happens when I start making changes and how the version are created, what happened in the background. So for that, I will go and use this notebook. Okay, so I hope you're all familiar. It's a notebook with code in Fabric. We can use a few coding languages, Python, of course, Scala. But here I just use SQL because I think it's most people here are probably familiar with SQL, so I'm using SQL for this demonstration. And every cell here contains code. Okay, so let's start using our code and see what happens. To see what happens behind the scene in the table, okay, I have a question. So is there a control of the sizing of the snappy file like one can do in Databricks? What better? Okay, so I'm going to talk about it in the second part of this session. I'm going to talk about the size of files and how it affects performance. Okay, so I want to see what behind the scene in these files. So I'm going to go ahead and use the OneLake app. Okay, and here it is. And I'm going to, what it does is it's like a OneDrive app. It sync data to your local drive just for OneLake. So here is the folder for my workspace, and in it, the folder for my Lakehouse, and the files and tables that we see here. I'm going to go to tables, and for now, I just have my orders table because this is not refreshed. Okay, the DMTBL is not really here. So I now have only one table and one folder. I'm going to go ahead and before we start, I will use schema so I don't have to write the schema on every command. Okay, so that's just to save time. Okay, I'm going to start by creating a table. It's called DemoTBL, and it just have one column. I called column one, and it's of type int. Okay, I'm going to go ahead and run this. So behind the scene, that Fabric now go and create a table. What it does, it just, okay, let's go back here. Sorry. Let's go here and sync from OneLake, and we should be getting any moment now. Okay, the DemoTBL folder. And it's almost empty. There are no data files, just a delta log file, a folder, sorry, that has one JSON file. We'll see later, the JSON file is a version. We now have one version of create table because we created a table. Okay, but there is no data yet. The data should be here. Okay, so I'm going to go back to my notebook and I'm going to skip on that. And I'm going to run insert into the DMTBL with the value 1. Okay, let's go ahead and run that. Okay, so now if I select from this table, I should get one row, right, with the value 1. That's it. And let's see what happened in our folder. Okay, so we now have just one file. Notice that it's the Parquet file, okay? And this one file, one data file contains our one record. So I'm going to stop now for a minute. I want to talk about the advantages and a limitation of Parquet files, okay, before we dive in and create any more versions. So I'm going to go back to my presentation and click on that. And it's always the other way around, so I need to swap. Okay, I hope you cannot see my presentation. Parquet files are open source. They are developed by the Parquet Apache organization. And that's an advantage because you can use Parquet files with other vendors. It's not vendor dependent. They are actually data files, but they are differ from other text-like data files. For example, CSV. In a CSV, I can put numeric data in a column, but I can also put alphanumeric data text in the same column. There is no data type that prevents me from making a mess, okay? And when a system tries to read my CSV files, it doesn't know which data it will get from a column. It has to read the entire file to make sure for example, it only holds numeric values. So Parquet is different because it holds the column metadata, the data types, in the column, in the metadata, in the header of the Parquet file. So that helps system that connects and read files to know which data type to expect. Okay, so that's schema, that's very important. Another advantage of Parquet file is that it's columnar based. What does that mean? CSV, for example, is row based. So when we open a CSV file in Excel, it might look like this, right? There are columns and rows, but actually behind the scene, it holds all the data in rows, one after the other. So let's say, for example, that I want to summarize this integer, the orange column. Okay, I will have to go and read this part and then read this part, read this part to get the value that I need to summarize. And if it's a very big file, it might take a long time. In a column-based storage, like Parquet files, each column is stored differently, alone, in different place. Okay, so if I now want to summarize, count, sum on or average on this orange integer column, I just have to read this part. Okay, so this is a very small example, but think about it in the gigabyte of data, how much time will be saved. Another issue, another good advantage of a Parquet file is compression. So Parquet data is compressed and it saves a lot of room on storage and a lot of time when we read this file or transfer it via the network. An example of compression, I have in the left side a table with ID column, order number, and status. How can I compress this table to get a smaller size but still keep all the data? So as you can see in the ID column, in the right table, I took out the 100,000 header of the value and just kept the 1, 2, 3, etc. And the 1,000 is stored in the header of the column. So when system reads this column, it knows to append it. Okay. So this is the truth for order number. Also, in the status column, this is a special case called a dictionary. So we just translate the open, close, cancel values in status to, for example, numbers 1, 2, 3, and we save the values, the hash values in the column, and the translation, the dictionary in the header. And now when the system reads it and wants to display it to a user or use it in a query, you just have to replace the values back. So the differences between the file before compression and after compression are very large. For example, I had a call for a customer a few months ago, and he complained that he lost data. He copied a table from SQL Server. It was, I think, 600 gigabyte table, and he copied it to Parquet files on Azure storage. And he called me and says, Chen, I've lost data. I just have, after the migration, I just have 100 gigabytes instead of 600 gigabytes. And I told him, okay, that's okay, because Parquet file uses compression, and it compressed the data from SQL Server. So he didn't believe me. I had to prove it, but that's another issue. Okay, so Parquet is great. We have compression, we have columnar. It's great for analytic data users, but what are its limitations? So basically, we have two very profound limitations for that. There is no transaction support. So if I now read Parquet folder full of Parquet files and another process writes in the same time, I might read part of a file. And I might produce a report that is not correct. Another issue is with updates and deletes. If I want to update rows inside a Parquet file, I can't. I can't update or delete rows in a Parquet file. I can't do a partially update. I have to rewrite the entire file or folder of data to update it or delete. Okay, so that's a limitation, and that delta, the delta format wants to resolve. Okay, so now we can go back to here, and let me remind you where we were. So we created a table, which created a folder, and I ran one insert into the table, and now we have one file. Okay, and it's a Parquet file, as we saw. And now I want to run two more inserts to add some data into my folder, and it will. Okay, come on. Almost there. Okay, I think we got it. I'm thinking again, and we got, okay, two more files, each with one row. By the way, I should clarify that usually Parquet files in a Delta folder doesn't hold just one row. Of course, it's just a demonstration, so I write one row at each insert. That's why I get one row per file. But usually we insert a lot of data at once, and we will get very large files or larger files. Okay. I'm going to go ahead and alter this table. So let's say I want to add another column called name. For now, I just have one column called one. Now I want another column called name. So I alter the table, and it will be of that type string. So let's run this. And I want to see if we got another file. So I'm thinking, so we didn't get a new file because it's just a metadata change. Okay, let's make some more changes. I'm going to update this table where call1 equals 1, so just one row, and I'm going to set the name to Chen. Let's run this, and let's run straight after this another command to delete the second row that you added. Okay, so I'm running this too. And I'm going to go ahead and run this cell to see what the current status of the data. So now I have just two rows. One has a name and the other one doesn't, and it's 1 and 3. And let's go here and see what's going on the files part. So we have 5 files. We'll explain why 5 in a minute. And if I go to the Delta log, I have 7 versions. Because it starts from 0, I have 7 versions. So let's go and describe this history demo.pl. I'm going to go ahead and run this describe history command, and I want to see what's going on in this version file. So there are 7 versions. It's the same. Let's say it another way. The data in the describe history comes from these JSON files. Okay. So we have 7 versions starting in 0. The first one is creatable. Okay. And then we had 3 writes. If you remember, I added a column, and we can see the column properties here. Then I did an update, and then a delete. Now, if I go to operation metrics, I can see that on each write, there was one file added, right? And on the update and delete, there was one file removed, but also one file added. Okay? So what's going on here? Insert is simple, okay? So when we insert it, we're getting files with data. That's obvious. What happens when we delete or update data? When we delete data, the undeleted data, so let's say if we have a file that has 10 rows and we deleted 5 rows, Fabric will take the remaining 5 rows and move them to a new file, and its version will mark the previous file as obsolete for this version. Okay, so on its version, Fabric knows to which files it should go to get the current status, the current data. For example, let's say that I'm going to go back to the actual files. If I want to see the version, the first version, let's say after I first inserted one row, I should just read these Parquet files. I think depends on the, yeah, that's the older one. So I just have to read this one, okay? If I want to see the next insert, I need to write this one, and this one, right? If I want to write to read the updated values, I have to write this one to read these Parquet files and ignore this one. And I read this and this. Okay, I hope that was clear. If it's not clear, please write in the Q&A and I'll explain it again. So let's go back to the versions. Okay, so versioning lets us do a lot of things that are very hard to do in a regular database, like SQL Server or Postgres or MySQL. For example, I can select for my table, but I want to see what was the status of the table in version 5. Version 5 was here after the update, but before the delete. So if now we have just 2 rows, before the delete we had 3. So if I go ahead and run this, I should get the 3 rows that I had before the delete. Okay, so this very cool feature is called time travel. I can use Delta version to time travel to see the data as it was in a specific point in time. Okay, so this is version 5, but I can also use, instead of version as of, I can use timestamp as of. So I will need to look at this time versions because if I ask for time version before the creation of the table, we'll get an error, of course. So let's see. I'm going to try for this version. So it's okay, and 719. Okay. So if I run this, I should get the data as it was. Sorry, I think I didn't change the seconds, so we got a little more. Okay, so the timestamp as of gives me the version that is the oldest one before my timestamp. Okay, the one closest to my timestamp. I hope that was clear. Okay, one more cool thing that we can do. We can use versioning to compare data on the same table. So I can select from this table as of version 1, join the same table as of version 2. And if I do that, I can see what was the changes in the data. So for example, okay, so here I see that in version 1, I just have 1 row. In version 5, I had the 3 rows, and I had the name column. I think that I can use this functionality to, for example, compare data from today to yesterday, or for last week. Okay, so version are kept for, I think, 30 days. Okay, and we can use it for this time. Okay, so we have a question. How does time travel in Fabric work internally? Will it store data every time? So time travel actually I just explain it. Time travel actually use the existing version, and every operation on the table, almost every operation will create a new version, and you can time travel to that version. Okay, the way it works behind the scene, it keeps all the data files, even one that are obsolete now that we deleted and updated, but it keeps it for compatibility with older version. So the file is not used when we select from it as of current status, but if we select of it as of older version, it will be used. Okay, I hope that was clear. Okay, just a few more demonstration. We can restore. So we know the files of the older versions. We can restore files. So let's restore to version 4. I don't even remember what was version 4 was. So I left to run the select to see. So version 4. Oh, okay. So version 4 was we already had 3 rows, but and the name column, but no, I didn't update the name column yet. Okay. So restore is very cool. If you add in an SQL server, for example, deleted accidentally, of course, accidentally deleted a table, and now you have to run to the DBA to restore the entire database, because that's the only way. That DBA has to restore the entire database to another database or another server, and then just copy the one table that you need back. So that's overkill, but here in Fabric, we just have to run a restore command, and bloop, the files are back, and no data was copied. Okay, so it just uses the version, the existing version. Okay, I'm going to go ahead and describe this history again to show you that restore is also an operation. So restore didn't deleted my old version, and now I can unrestore. There is no unrestore command. I mean that I can restore to an earlier version again. Restore doesn't keep me from using the old version. Okay, there are some operations that does not create a version. Let's go ahead and rename the table to demo TBL1. Okay, so I'm going to go ahead and rename the table, alter table, rename. And if I go here and run sync, I can see that. Okay, you can see that. Okay, so the only change is the name of the folder. There is no new version here, here. Okay. Sorry. So renaming is not version creating operation. I'll go ahead and rename it back so my future comments will not fail. One more cool feature connected to versioning that I'm sorry, but I can't demo it here because it requires a warehouse. I can clone tables. So I can run a command, create table as clone of other table. It creates a new table, but it does not copy any data. It just relies on the last version of the previous table, the stores table. And now I can delete, update, make any changes that I want to the new table without affecting the old table. Just create new version in my new table, my new table folder. I can delete the new table. It does not affect the old table. And it's great for testing purposes because you have, I don't know, a very big table and you want to make changes, but you don't want to ruin it. So you can go and clone it and just use it. For some reason, Microsoft decided that this feature will only work on Warehouse in Fabric, but not on Lakehouse. I don't know why. And that's why, as you can see, this command has failed for me. So, sorry. Okay, so Delta tables are great. We can travel through time. That's amazing. And they're very useful in queries and stuff. But they have some maintenance issues, some performance issues that we need to look into and let's say put our minds to prevent bad performance. So I'm going to go ahead and switch to this notebook, and I'm going to go ahead and run this use schema command. The first issue is with many small files. For example, in my demonstration of the demo TBL, each insert created a new file. And so I just had I just had 3 inserts, but let's say we have many inserts and each one create a file. That's only if we have small insert, small updates, each one create a file. We might have a folder full of millions of files, and when Fabric tries to read these files to select from this table, it will take a long time because reading from a lot of small tables is poor performance. So we can use the optimize command to optimize the file structure. So if you remember, we have the 5 Parquet files. So I'm going to go ahead and run optimize. What happened in background? Fabric looks at these small files and decide if it needs to combine the data into larger files. So here, of course, we have a lot of little files, so it should, okay, let's sync again, and we should get a new file. What happened? Okay, I'm not sure what happened, but we now have a new file that is a bit larger than the other ones because it contains all of the data in the other ones. So you might want to ask, why didn't it deleted the old files? Okay. If it took all the data in the old files and put it in one big file, why didn't it delete the old files? So the answer is that I'm going to go ahead and describe it. It keeps the old files for version purposes. So I have a history and I can time travel. If I want to remove old files, so you can see that the optimize is another version, okay? And I can go ahead and see that the number of removed files are 3, okay? And added files is 1. So they are not actually removed, they're just ignored in this version. If I want to actually remove old files, let's say that I have a very large folder and I optimize it and I have my new larger files and I now want to actually remove the old files, I have the vacuum command. The vacuum command, I'm going to go ahead and run it. Vacuum command, delete old file based on my parameter of how long keep. The default is 7 days, which is why nothing will happen there because all my files are new. But you can run vacuum occasionally to remove old files, but you should run optimize. I run optimize on a daily basis, but daily or every few days should be good. Okay, so we talked about what happened when we have a lot of small files. That's not good. We need to optimize. What happens if we have larger files or a lot of files and we want to get the data for a specific value? In working with relation database, SQL Server, we have indexes, right? So we can add where to our select and get the exact data rows that we need. But in Delta files, we have no indexes. So how can we prevent what's called a full scan in databases, reading the entire data file, data folder, to get the data, which may be very expensive and slow. So option 1, partitioning. Okay, to demonstrate it, I will use Python now. So if you're not familiar with it, I can use this magic command and with PySpark, and it will run this cell, although the entire notebook is Spark SQL, this cell will run in PySpark. So I'm going to go ahead and run this. What it will do, it will read from the orders table and put the result into a data frame called orders df. I can display this orders df data frame. And I want to choose the column to use as a partitioning column. I'm going to use the customer ID column. I'm not sure it's a good partition column candidate. Usually we should use some kind of date, year, month, day, etc. But for this example, I will go ahead and use the customer ID. And also for this demo, let's say that we want to read the customer ID of this one. Okay, so HILAA. Okay, so I'm going to run this command with write from the data frame write to the table called orders partitions and partition by customer ID. Okay, let's go ahead and run this. And okay, I want to see again behind the scenes what happened. So I'm going to wait for this command to complete. So we get a new table. Okay. Think for one again. Okay, we have the order partition table, and the difference from the table I used before, that each partition is in a different folder under the root table folder. The delta log is the same for all partitions. And for example, the data for this customer is right here in a Parquet file inside the customer folder. So if I now go to my notebook and select from this table where customer equals this customer, I'm getting this back, this 6 rows. And what happened behind the scenes, Fabric just had to go to the folder and just read this customer ID equals customer equals name folder. Okay, it doesn't have to read the entire folder. Again, this example is very small, but on a large scale, it can save a lot of time and compute. So that's about partitioning. Partitioning is great for some use cases, but in other use cases, we might want to use dead order. That order is used with optimize. So I'm going to optimize the order table. I'm going to order the orders table and that order by customer ID. Okay, let's run this. And what does it do? It optimizes, so it collects small files and combines them into large files, but it also stores the data into files based on customer IDs. So, for example, all the customers starting with A, B, and C will be in one file. The one starting with D, E, and F will be in another file, and that depends on the data size. Maybe if it's a very large table, then just the customer that starts with AA will be in one file. Okay, and it holds a minimum maximum, okay, of the customer ID, and that's how it knows to which file to go. So if I go to the orders table, okay, okay, there are only seven files, but in each file there are only few, I'm not sure what the word, starting letters for the customers. So all the customers in A, B, and C are here, and okay, understood. And when I now wants to read where customer ID, it only has to read some files, not all of the folder. So that order is also very useful. By the way, we don't have just to use, we can use multiple columns. Okay, so I can that order by, oops, sorry, I don't know, order date. Okay, and it will order by these two columns. That order is used in other vendors too, but Microsoft has introduced vOrder. So vOrder is compatible with Optimize and with that order, and it works on a different level. vOrders actually change the internals of the Parquet files. It will sort the data inside the Parquet files and build it in a way that will work faster in most of the cases. So vOrder will take longer to create, but it might improve performance on select to some extent, sometimes by 50%, Microsoft said, but it depends on the situation. So any questions so far? Okay, feel free to ask me via the question Q&A button. Okay, I want to go back for a minute and recap a bit of what we talked about today. So Delta tables are important for the proper functioning, or essential for the proper functioning of our data of our lakehouse. So Delta table are based on Parquet files, and we get the schema, the columnar ordering, and the compression, which save us time. To overcome the limitation of Parquet with transaction and update, delete, merge, Delta Lake introduced the transaction log. Okay, so we have transaction support, we have updates and deletes, we have time travel, which is cool, and we talked about a bit about cloning, restoring. If you want our Delta tables to work properly, we should notice that we don't have too many small files when you can use Optimize to fix this. To get better performance from queries using where or join, we can use partitioning, we can use Z order and V order, which is new in Fabric. Thank you all for attending my session. It was great to be here, and looking forward to seeing you in other sessions and conference.